Hello, it's Mr. Kaladi here, and now we are finally ready to solve some exponential equations. So we've kind of hinted at this, we've done some questions before, now we're going to learn all the different techniques. Reminder, an exponential equation has an equal sign. That's what makes it an equation. All the other functions we've ever learned, we know how to graph them, transform them, and solve equations involving them. So now we're going to learn how to do that with exponential equations. So you've already kind of been exposed to some different methods. The first one should hopefully be review. This is the one where we equate the exponents. So for example, if I have a question like this, 3 to the x plus 1 equals 3 root 3. So there's an equal sign, so it's an equation. You have to solve for x. Figure out what value of x makes this true. This is difficult to do because the unknown, is in the exponent. The first thing you can do is rewrite this question into something that is a little easier to understand. So this is 3 to the power of 1 times 3 to the power of half, because the square root is a half. And then I can add those exponents. So that gives me 3 and 3 over 2, or 1.5 basically. Now, what I've showed you before, another teacher's probably showed you how to do this. If the bases are the same, you can equate the exponents. So x plus 1 is equal to 3 over 2. So that is my first method. Now this is an easy grade 9 question. Subtract 1 from both sides. So this is 3 over 2 minus 2 over 2. I just turned the 1 into a 2 over 2. And I get x is equal to a half. That is the value that makes the statement true. Let's do a question similar that has an extra step. So here, okay, well, I'd like to solve for u. It's in the exponent. My strategy is to have the bases be the same, but they're not. This is 250 and this is 5. Plus I have this 2 in front, which is a problem. Let me get rid of that 2. So let me divide both sides by 2. So I end up with 5 to the power of u plus 5 is equal to 125. Well, now I can set this equal to 5 to the power of 3 and rewrite it that way. Now, because the bases are same, I can use my rule and set the exponents equal to each other, and u is equal to minus 2. Even a really crazy question like this, I can use the same strategy. I set the exponents equal to each other if the bases are the same. Now they're not the same yet, but this is 3 squared. 9 turns into 3 squared. And then I can rewrite it as 3 to the x squared minus 5x plus 2 equals 3. I gotta multiply here, 2x plus 2. Now, the bases are the same, so I can equate the exponents. X squared minus 5x plus 2. Now, just like that, it's a quadratic question. I collect my like terms, so I end up with x squared minus 7x. The 2's cancel out. Factor this to solve it, so I end up with x times x minus 7. So I have two answers, x equals 0, x equals 7. So in each of these steps, once I get a situation where the bases are the same and there's nothing else in the question, no other coefficients or anything, then I can equate the exponents. So that's one method for solving an exponential equation. The second method, and you can't do this all the time because there are cases where you can't make the bases the same, so you're stuck. The second method is to convert the exponential equation to a logarithm using the definition of a logarithm. If you remember, the logarithm and exponential functions are both related. They're inverses of each other. And I know that I can write this as log base 2, the argument is 30, is equal to x. So x is approximately, let me get my calculator. Again, you don't have this calculator yet, but essentially this is now just a number. It is log base 2 argument 30. So it's approximately 4.91. Similarly, question like this, solve for x. Well, I'm going to rewrite it as a log. So I have log base e of 7 is equal to x. In other words, x is equal to ln 7. Well, that's easy. I can type that into my calculator, even my regular calculator. Ln 7 equals 1.95. So sometimes you are going to have a situation where you're able to convert to a logarithm. Sometimes this will not work as well. So now we're going to show you the third method. And the great thing about the third method, this always works. And this is the method of logging both sides. And you might have seen it before. Now we're going to do it for real, and we're going to you know why it works. You've seen all about the log. So now we're just going to go through this strategy. So let's say you have an exponential equation. The x is unknown and it's in the exponent, so I don't know how to solve this. Well, what you can do is log both sides. Remember, what I do to one side, I do to the other. And in practice, what this really means is I write log in front of this and log in front of this. So I have log 2 to the x equals log 30. Resist the temptation, just think logs fell out of the sky. I did an action. I took the logarithm of this side, I took the logarithm of this side. Similar to how you could square both sides or subtract 2 from both sides, you can log both sides as well. Now, once you get this done, you want to solve for x using your log laws. One log law that we know is that the third log law, I can bring this exponent down in front. That's a valid thing I'm allowed to do. So now the log 2 to the power of x becomes log 2 equals log 30. Now, my whole problem was I wanted to isolate for x. So I need to get rid of log 2. Remember, this is log 2. This is a group. Like, this is something where if you go to the top of the school and say, hey, what's log 2? Someone's going to shout it back to you. This is just a number. If you want, we can calculate that number right now. Here. Log 2. Yeah, it's 0.301. So don't separate the log and the 2. They go together. Excuse me. They go together. I'm going to divide both sides by log 2. And I get x is equal to log 30 divided by log 2. I type that into my calculator, so log 30 divided by log 2, and I get approximately 4.91. So that is my strategy. Now look, when I logged both sides, it doesn't really matter what base you choose, right? Like I chose base 10, which is the one where you don't actually write it in. Why did I choose base 10? Because that's the log that's built into my calculator, my simple calculator. So I know I'm going to be able to get a final answer. Watch another solution method for this question. What if instead of logging with base 10, I logged with another number? So I logged both sides. What's a more clever base that I could use? Well, if I did a log base 2, again, it has to be the same on both sides. Look at what happens. The 2 to the power of 2, these two undo each other, right? They're inverses, so I'm left with just the x. So my answer is log 30 base 2. So I used here a clever choice of base. And I got this answer. These are the same. In fact, if you look at this question, if I were to apply the change of base formula, it would give me this answer. Right? So log 30 base 2 is really log 30 over log 2. Choose whatever base you like. The difference between these two answers is really the type of IB exam you're doing. If you want an exact solution, that is if you're doing a paper 1, a paper with no calculator, this is how you would solve the question and you would just submit that answer. That's a valid answer for somebody. If you had a paper 2, a calculator exam, then you would give an answer like this. Either way, the solution method is the same. you log both sides. And then you use your log manipulation to find the final answer. Let's do another example. So I see this question here. I have an exponent unknown in my exponent. I know I have to use one of my three strategies. I'm going to log both sides. But actually, before logging both sides, let me get rid of the coefficient. So let me divide both sides by 20. That's going to leave me with e to the 2x is equal to 42. Now I'm ready to log both sides. But I probably don't want to log both sides. I probably want to take ln of both sides. That is, I probably want to take log base e of both sides. When I do that, the log base e, or the ln and the e, undo each other, so I'm left with 2x. And on this side, I have ln 42. So when I divide both sides by 2, I end up with a final answer of ln 42, which is divided by 2. And that's a valid exact solution. You could type in your calculator and get a number. Just be careful. This is not ln 21. We never taught you a rule that allows you to do that. Ln 42 is some number, but to divide it by 2, it does not mean it's just ln 21. So be really careful you're not making up math. Phew. So that's our methods for solving exponential equations. This is great. The rest of our lesson, we're going to do some practice. But actually, before we do that, let's go back to that Facebook question we did when we learned exponential functions, lesson 1.3. We were trying to solve this equation. So we subbed 1,000. It was like, I think, 1,000 months after Facebook started. No, when does Facebook have 1 billion users, or n equals 1,000? What is x in months? So we're going to sub in 1,000, 1.32, 1.1 to the power of x. Okay, so to solve this, well, first of all, I'm going to get rid of my coefficient. I don't like having coefficients. It just complicates my solution. So I'm going to divide both sides by 1.32. Ugh, I did it wrong. 1,000 divided by 1.32. That gives me 757.576. Note that I use many significant figures in my ancillary steps. I'm not going to round it till the very end because I'll lose some information. This gives me 1.1 to the power of x. Now, we've since learned that the way to solve this is to log both sides. And now what's amazing about logs is I'm allowed to bring that variable in the exponent down. So now this question becomes x is equal to log 757.576 divided by log 1.1. So I'm going to take the log of this number divided by log 1.1. And that gives me 69.6, around 70 months. Neat. In 70 months, Facebook got 1 billion users, so we were able to figure it out. Okay. So I have 3 sections of practice for you here. Again, what I'd recommend to do is pause the video and try to do these yourself. The first section, you're going to find an approximate solution, so you're going to use your calculator, your regular calculator. The second section, you're going to not have your calculator, you're going to try to use a clever use of log laws. And then we have an advanced question down here. So try those now on your own. Okay, welcome back. Let's work through these practice problems. So we have a logarithmic equation. How is it logarithmic? Well, it has an unknown in the exponent and it has an equal sign. So I need to find out what the x is. It would be really difficult to make these the same base, so I'm going to log both sides. Log 3 over 4 x equals log 0.1. Okay, now my great thing about logs is I can bring the x down using that log law, and then I can rewrite. I can divide both sides by log 3 over 4. And now I just type this into my calculator. So log 0.1, which should be a negative, divided by bracket Actually, sorry, divided by log bracket 3 divided by 4. And I get 8003922. So if I round that to 3 sig figs, 800, 8.00. Okay. Should I make a note here? I've never made a note before. 3 sig figs. Okay, next question. So I want to solve for t. I've got a problem. I got to get rid of the 200 first. 6 divided by 200. 0.03 is equal to 2 to the power of 0.04t. Now I need to log both sides. Maybe you're thinking, no, I think I'll just log. Let's try logging base 2 just to see what happens. So I'm going to log both sides, but I'm going to log base 2 instead of base 4. Or sorry, base 10. So now I have, okay, I have the same situation. I'm allowed to bring down this exponent, so I get 0.04t times log 2 base 2, which is just 1, right? Yep. And then now I can solve for t. So t is equal to log base 2, 0.03 divided by 0.04. This is all great, but I can't solve this on my regular calculator. So I would need to use my GDC, which is more powerful. I'm going to press log base 2, 0.03, divide that answer by 0.04. And I get an answer of negative 126.472. If I round that to 3 sig figs, it's negative 126. So that was using my GDC. Or the change of base formula. Okay, let's keep going. Got a question like this. Again, it's exponential and it's an equation, so I only have a few options. I cannot make my bases the same, so I'm going to log both sides. Log 5 to the x equals log 2x plus 1. Now I can bring my x's down, and I can bring my x plus 1 down. Okay, now x log 5 makes sense to me. What's going on here? Well, remember, log 2 is just a number, and I'm going to write actually that up here. Log 2 is equal to log 2 is approximately 0.301. It's just a number. You go to the top of the roof and you could say, hey, what's log 2? And someone's going to shout it back to you. So this is just a number that, and this is being, so it all goes together, this is being distributed to both of these things. Sorry, it's going the other way around. This 0.31 times x, 0.31 times 1. You could even write log 2 as 0.31. That's okay. I'm going to write it like this, x log 2 plus log 2. Now, let me collect my like terms. So I'm going to get all my x's together. X log 5 minus x log 2 equals log 2. I'm going to sub out or factor out my x, so I get log 5 minus log 2 equals log 2. And now I'm going to divide. So I have log 2 divided by this expression, log 5 minus log 2. Now I can type that into my calculator. Log 2 divided by open bracket, log 5 minus log 2, close bracket, 0.756. So when you have your calculator with you, you're able to always log base 10 is probably the most reliable thing to do. So if you have a word problem and you have your calculator, just log base 10, use that log law, and you should be able to solve for x. Let's say you have questions that you don't have your calculator. So this is a paper 1 question. You're going to have to be a little bit more clever. To solve this equation, this exponential equation, I should be looking for some strategy. Well, I noticed that 8 and 4 are both the powers of 2, so I think I can get this to have the same base. 8 I replace with 2 to the power of 3. 4 I replace with 2 to the power of 2. Now I can simplify the log, so it's going to be 6x plus 3 is equal to 2 to the power of 10 minus 2x. Now because the bases are the same, I can set the two exponents to be equal. So I get 6x plus 3 is equal to 10 minus 2x. I bring the 2 to the other side, I get 8x is equal to 7. So x is equal to 7 over 8. Look how I had to use some clever thinking to find this solution. Okay, so let's look at this next question. This is an equation, and it's an exponential equation because x is in the exponent. So, can I make the bases the same? No. I can try rewriting this as using the definition of exponent, or I could try logging both sides. Now, if I log both sides, what base should I choose? Well, if I choose the base of e, then this I can get rid of the e here. In other words, if I write ln e to the negative x over 2 equals ln 16, now the ln and the e, they undo each other. So I'm left with negative x over 2 is equal to ln 16. To get this by itself, I multiply both sides by 2, and then I multiply by negative 1, so I get x is equal to negative 2 ln 16. So that is a valid answer because you don't have a calculator. You can't really simplify it any further. Well, I mean, technically you could do this actually. Ln 16 to the negative 2. So that's ln 1 over 16 squared. But I can't really do that with a calculator. Okay, my final question. How do I solve this without a calculator? Well, let me first start off by trying to get rid of this coefficient, 7. Let me see if that helps. I end up with 6, 2y minus 4, and this is equal to 8. I still have a problem. These aren't the same base. I cannot make them the same base, but I can log both sides. Which base are you going to choose? You have to choose some base that's going to help you out. I want to try to get rid of this, so I'm going to log base 6 both sides. This effectively undoes this, so now this side is just 2y minus 4 is all I'm left with. This side I have some difficult log 8 base 6. I don't know what that is, but if I could get to the top of the roof, or if I could get the calculator, I could figure out what number this is. Now I can try to get this by itself. Log 8 base 6 plus 4. So I brought the 4 to the other side. Notice that even though I didn't show any brackets here, this plus 4 is technically outside of this argument. If the bracket was out here, it would be in, but technically if it's not shown, the bracket is just around the first number. Finally, I divide the whole thing by 2. And there's my final answer. That's an exact solution. I can't go any further without a calculator. Okay, finally, can I show you a more challenging question? Here we have two curves. This is curve 1, this is curve 2, and they're both exponential. They're both a natural exponential. How do I find the point of intersection? I didn't give you a hint. Well, to find the point of intersection of two curves, what we taught you in grade 10 was to set y1 equal to y2. So I have e to the 2x plus 6 is equal to 3 plus 4 e to the x. Okay, let me try bringing everything together so I have on the same side. So I have e to the 2x minus 4 e to the x plus 3 equals 0. Now, I don't know if you see it, but this is actually a quadratic. Maybe if I rewrite it like this, e to the power of x squared minus 4e to the x plus 3 is equal to 0. This is a quadratic. It's a variable squared. The second term has just the variable. The third term is a constant. If you really want to see it, you could use the substitution. Let a is equal to ex. This was in our little hint up there. So now this is going to become a squared minus 4a plus 3 equals 0. Now it looks like a quadratic. And to solve a quadratic equation, well, we've already spent a lesson reviewing this. I have to factor. So I have a, 1 is going to be minus 3, 1 is going to be minus 1. So now I have my two solutions. I have a is equal to 1, a is equal to 3. Of course, the question's not asking you what a should be, it's asking you what x should be. So I have to go backwards with my substitution. I have to sub back in a equals e to the x. So I have e to the x then is equal to 1. If I ln both sides, the ln and the e undo, so x is equal to ln 1, which is log of 1 is always going to be 0. Right? If you don't believe me, ln 1 is always 0. Similarly over here, I sub in for a e to the x, so I have e to the x is equal to 3, ln both sides. The ln and the e undo each other, so I'm left with x is equal to ln 3, which is some number. You can go to the roof and yell out, what is ln 3? And someone will tell you. Whew, so there's our big lesson on solving exponential equations. Finally, what a great skill we have learned. Let's practice it with some homework. Page 128, number 1 to 2, and number 1 to 3. Wow, only 5 questions. I wish there were more. Good luck with your homework, and we'll see you next time.